So welcome everyone. Today, 8E, this will probably be the shortest exercise that we do. It's a nice short exercise on the standard normal distribution, and then we can get into the exercise in the textbook and some of your folio work as we've been doing. I'll just talk about this sheet that I've just handed out to you. What we've got here is question 2 from both the 2018 and the 2019 exam. And they're both a great example of how they can ask a pretty basic continuous random variables question. You can basically do all of that after today's lesson, except C of the 2019 one, which is this one. So you'll be able to answer all of it, and then as of tomorrow, we'll be able to answer the whole thing. Okay, so probably the one that you would start with is going to be this one with all of the graphs on it. That's the one you can do today, and then maybe tomorrow we can have a go at that one once we've learned how to do the skill we need for part C, although it is a skill that you cover in 11 methods as well, so you might remember how to do it. Okay, so let's get started on what we're talking about with 8E. We're talking about the standard normal distribution. So basically a z-score is a measure of how far a given result is from the mean, okay? So from the mean, we have the average result, and a z-score tells you how far away a given result is from the mean. So this is the formula we use to calculate a z-score. We've got Rob achieved 83% on his math test, which had a mean result of 74% and a standard deviation of 6%. And then we've got his results for English. Which test did he do better on? So if we're going to calculate his maths test result, okay, the z-score for his maths test, it's equal to his result, take away the mean, divided by the standard deviation. So his result was 83%, the mean is 74%, and the standard deviation is 6. Okay, that's all we're evaluating. All right, we're left with 9 on 6, which is 1.5. Now, what this means, okay, here's a z-score of 1.5. The z distribution is a distribution that has a mean of 0 and a standard deviation of 1. So it looks a bit like that. Now his result is a z-score of 1.5. That is here. That's Rob's maths result. So that means his maths test result is 1.5. His z-score was 1.5. 1.5 standard deviations above the mean. Okay, 1.5 standard deviations above the mean. That's how well he did relative to the rest of the class. We can see he did better than average. In fact, we can calculate how many people he did better than. Okay, let's do it for English. The z-score for English is equal to his result, which was 62%. So you might think, gee, that's way lower. But the English test was pretty hard, and the students had an average result of 55%. And the standard deviation was 3. So what have we got there? 7 on 3, which is 2.3. Okay, so that means even though he performed worse, his result wasn't as good. His result is further above the mean. So for maths, he got a standard deviation of 1.5, a z-score of 1.5, and for English, 2.3. And so if we compare these two different distributions, okay, if we compare these two different distributions, we can see his English result is higher up the curve, better to the rest of the class than his maths test result was. Okay, so the question is, which test did he do better on? The answer is English, because it's further along the distribution. Okay, so that's what we're doing in this exercise, is comparing different distributions that would normally seem different, and yeah, this is the way that we do it. We'll get into our second example, and I can explain this notation again. Given x is normally distributed with a mean and standard deviation squared. Okay, so that's the notation. We have a z distribution, so this is some x distribution. The z distribution is a normal distribution with a mean of 1 and a mean of 0 and a standard deviation of 1. Okay, and we're asked to calculate this. The probability of the mean, take 2 sigma, being less than x, being less than the mean plus half sigma. is the same as the probability of A being less than Z being less than B. Okay, so if we have some normal distribution, we don't know what its mean and standard deviation is, but I'm going to explain this in a way that is more complex than it needs to be. Okay, it's just so that we arrive at the answer. We have the mean plus sigma, mean plus 2 sigma. We have the mean take sigma and the mean take 2 sigma. Okay, now we're asked, what's the probability of this event? Okay, so that's the mean take 2 sigma to the mean plus half sigma, which is here. So it's this region on the normal distribution curve. Okay, but what it's saying is, what are the corresponding z-scores? What's A, which is 2 standard deviations below the mean, and what's B, which is half a standard deviation above the mean? Well, the z-score, if we think about the z distribution, it has a mean of 0 and a standard deviation of 1. Okay, this point here corresponds with a z-score of -2. The value of A is -2. And this point here corresponds with a value of a z-score of positive 0.5. It's half a standard deviation above the mean, so the value of B is 0.5. We're not even asked to perform the probability calculation, we're just asked to find the values of A and B. Okay, so that pops up a little bit later in the exercise, and the reason I go over this is because it's a question that pops up in the textbook for us to address. Most of the exercise is dedicated around question 1. Okay, so that's it, 8E. Any questions from you guys? All right, let's have a crack at 8E. 8E and the question that I gave you on the sheet.